Good morning, everyone. I'm Mayank from the Department of Civil Engineering, Noida International University. Now we are going to start from the lecture 3 of the structural design and engineering. As per the previous lectures, we have seen what is a design, what is the prerequisites of design, and which comes first, design and analysis. We have seen some analysis part, and we have seen some design part also, okay, why it is so important for a design of any structural member. Now in this particular lecture, we'll see the different load action criteria on the structures which is used for the design of any structure. Going further, let's go and see slide by slide. The one which we have discussed earlier, the what is design. So we all know design is a mixture of art and science, combining the experience of engineer and their intuitive feelings for the behavior of a structure with a sound knowledge of the principle of static, dynamics, mechanics of materials, and the structural analysis to produce a safe and economical structure. As we have discussed earlier, the most important priority, the first priority of any structural design engineer should be the safety of the structure and the economy part, because any structure which is started, very small projects will start from the 100 crore rupees, minimum of 100 crore rupees and the crore of rupees. So we have to take care of these two aspects. The first, we should not be compromised on the safety part, and the second one, we should never be compromising on the economical part, because we have the limited budget always. Now the structure should always be safe and economical, and it should serve just in one intended purpose. It means the structure which is designed for should have served that particular purpose. Just like if you are designing an institution or an educational institution or hospital buildings or residential structures, so that particular structure should serve that particular intended purpose for that the particular structure is designed for. Going further, we will have the load condition. Let's discuss about what is load and why it is important to know about the loads and to know about the design loads. To design any structure, any safe and economical structure. So because based on their particular functional requirement, the nature of load should be which is required to design any structure to make it safe and economical. So we need to have a design load which is working on the particular structure, so we can make a structure a safe structure and economical structure. We should not base any material if the particular structure is designed for the particular load. So that particular the structure should have the different member criteria. The member should have the particular thickness as per the design load which is working on it, so that in the after analysis we can make the structure safe. Going further, the Indian standard, as per the Indian standard IS codes, there are IS 875, which tells you about the code of practice for the design loads. That code of practice is divided into the 5 parts, the part 1, 2, 3, 4, 5 and 4 and 5. These are the different kind of load which is imposed on the particular structure, and this load will not be having the earthquake load. The earthquake load is calculated as per the different IS code, which is IS 1893 for the building and structures. These all loads are just for the building and the different kind of structures. The 5 part of the loads are the part 1, which gives you about the dead loads. The second one is the imposed load, which also we call as a live load. The third part talks about the wind loads, which works on the structures. Fourth part is the snow load, and the fifth part is the spatial load and their combination of loadings. Going further, let's go and let's discuss about the IS 875 part 1. This is about the dead loads. Now these particular parts tells about the unit weight of the building materials and the stored material on the particular structure. That is basically the dead load, the self weight of the particular structure, and the weight which is imposed on the particular structure which is in dead in nature, right? So so as per the IS 1875 part 1, so it says any structure required the minimum design loads. The minimum design loads to ensure the structural safety and their economical part. So it is having the 3 scope. The first is the material scope of the materials. The second is a part of the component of the structures, and the third is the stored material, the material which is stored in the particular structure. Particular structure will have a different unit weight, and which is given in this IS code. We'll see a table or form So it's give you about that. The first one, which as per the scope, is the material. The first is the material we can see in that particular table number 1, which is gives the unit weight of the building material, right? And it tells about the common burnt clay brick. If we talk about the bricks having their own weight, so these kind of different type of bricks which we are having, they are having the different weight and masses, and it is given in the kilonewtons, kgs, and kgs as per the IS code, as per the IS 875. Now the second one is the cement, concrete, and reinforcement. You can see that one. If it's having the different kind of cement, concrete, so it is having the different unit weights. Okay, as per the steel, which we are having the unit weight also. Just like if you talk an example of that, as per the IS code in the table number 1, it says key with the 1% of steel, if your structure is having the 1% of the total mass, total volume of the steel is given as a 1%, then the weight which design load or the weight of the structure is calculated as per the table, which is given as a 22.75 to 24.20. So these should be the unit weight or mass, which will be calculated as a design load. Now going further, the building parts. If we talk about the building parts, the second scope, which is given as per the IS code, is the building parts. If we talk about the building parts, which is given in the table number 2 of IS 875, and it talks about the ceiling. If we take an example of that, building parts, the first one is given as the ceiling. If the ceiling of the structure or the building or any room, which is having the plaster on the tile or the concrete, it will have the nominal size which is given in the 1.3 centimeter. So it will have the weight of 0.25 kilonewtons. Same like that, if you're having the plaster on the wood lathe, if you're having the suspended metal part lathe on the component plasters, the suspended metal part on the gypsums, so it will having the different unit weight, which is calculated as per the nominal size or the thickness of the particular ceiling plaster. Going further, which is having the third scope, which we have discussed, which is given in the IS 875 part 1 of the dead load. It says it is given the appendix A in the clause number 1.1, or it says about the store material. If you're having a kitchen, if we take example of the kitchen, and if you are a storeroom which will having the material which is stored that particular part of the building. So if we take about the each and every materials, right, just like example of this agriculture and the food products, it will have just like take example of the butter, coffee bags, drinks, just like a eating oil, fish meals. It will having the different unit load combination on giving per unit volume. It is given like that, weight per mass. It is given the kg per meter cube and the kilonewton per meter cube. So each particular food items or the food products will have the different unit weight, unit per unit volume. It will have the different weights which should be considered at the time of designing, so that the structure should be made safe and economical. Going further, as per the IS 875, we will have a small exercise on it. You can have the 3 or 4 different materials, just like the example of steel, plain concrete, reinforced concrete, and brick masonry walls. If you have these 4 materials, kindly write it down. The design unit weight of these particular materials. This is the most common material which is used for the construction of any structure, like just like a steel, plain concrete, reinforced concrete, and brick masonry walls. So we can clearly calculate the dead loads of the structures, and so we can analyze the structure after combining these particular loads. The first we have discussed about these particular dead loads. Now the second part of the IS code, IS 875, and this is called imposed load, that is basically called live loads. So what is this? It is called the code of practice for the design of loads, that is other than the earthquake load, for the building and the structures. And in the part 2, it is given all this about the imposed load, the live load. It is having the live load. If you talk of the live load, this is a minimum design value for the structure safety and economy that exclude those due to the construction, acceleration and braking. So if you talk about the construction, right, so the people are making that particular structure, and this is a moving load which is working on the particular structural member. And if you talk about the bridge structures, which is having the different vehicle loads, which is having a live load, and that particular load is basically live and dynamic load both. So it will change, the load will be changing with respect to the time. So it is basically nothing but the dynamic load or the live load. And so these creates the load on the particular structural member, so that we have to calculate the particular load, and after the combination of these loads, and we make the structure as per the required load. Okay, so going further, the imposed load and live load, it is the greatest load that probably will be produced by intended use or the occupancy. Okay, these are not the dead loads. This is the loads which is applied after the structures is made, and these are the movable loads, movable partition. If you include the movable partitions, impact and vibrations, load applied suddenly, dust, etc. The sudden load, which just like a load which is applied suddenly due to the heavy traffic or something else, so that should be calculated as the imposed load. Next, we go for the imposed load, live load, the use of group of buildings. So we have the different kind of buildings having the different imposed loads. Just like a assembly hall, if you have an assembly hall, this will have the different kind of load conditions. Business structures, offices, educational institutions, industrial structures, and mercantiles, just like residential structures, and the storage. So these all structural components, so the structural group of buildings having the different imposed and live loads depending upon the occupancy or the use. The next one, which we'll have discussed about it, the imposed and live load, just like a take example of a floor of any structural or the residential building. Okay, it will have the residential building, it will have, then all the rooms and the kitchen will have the different load condition, which is given in the kilonewton per meter squared per unit area. The load is applied on the particular structure is given as per the table number 1 of IS 875 of part 2. Okay, so it is all about is given in this particular table. The next one is the imposed load for the floor, which is just like that. First we have talked about the educational institution, just educational institution. This is a residential building we have just seen, and then the second one is for the educational institutions. So educational institutions will have the dining rooms, cafeterias, offices, lounges, dormitories, projection rooms, kitchens, so yeah, toilets, and the storerooms and all. So it will having the uniformly distributed load, which is in kilonewton per meter square, which is given as per the table number, table of the IS 875. Then going further, which will have the imposed load of assembly building. Just take example of that one, which is also given in the tables, and that is all the loads are in the UVL in the terms of the UDL, and it is having the unit of the kilonewton per meter square. This like a projection, storage, everything. Just like the next one is the mercantile building. So it will have in the retail shops, it will have this wholesale shops, it is having the different unit load and the uniform distribution load, and it is always having the concentrated load after multiplying the length of that. Industrial building is having the work areas without machinery and equipments, and work area of the machinery and equipments, the length duty just and the medium duty, heavy duty machines. If you have these kind of machines, then the uniform distributed load will be higher as per the area occupied by the particular machine. Now, the imposed load of the roof structures. So if you're having the roof structures, so this will have the different load conditions as for the uniform distribution load. As per the table number 2 of the IS 875 part 2, it is all given the imposed load on the various type of roofs. So different roofs having the different load conditions. And if you have any query about this particular IS code 875 and the different load conditions, you can contact me on the mayank.rai@nio.edu.in. In coming lectures, we are going to discuss further about the IS 875 of part 3, 4, and 5, and we discuss about something about the loads, which is due to the earthquake loads, which we are going to discuss about the IS 1893 of 2002. That's basically especially used for the earthquake design loads. Thank you guys, and we'll meet you in the next class. Thank you so much.